In this problem, a comet is traveling around the sun, and a comet has a very elliptical orbit. So at some points it's going to be closer to the sun, at some points it's going to be farther away. And so let's say at its closest approach to the sun, it's traveling 53 kilometers per second. So up here at 0.69 AU, traveling 53 kilometers per second. Out here at its most distant point, let's say that's 36 AU, and this is definitely not to scale. What is the speed at that location? So what's going on here is we're going to have conservation of angular momentum. That if we look at an object's mass times its velocity times the radius at any one location, should have a number 1 there, that's got to equal the mass times the speed times the radius at another location. And so we have our 2 points. We'll call this distance number 1 right here, 0.69 AUs with speed, first speed of 53, and then we'll solve for the second speed if our second distance is 36 AU. So this is the same comet at either point. We'll say the mass here is constant. Comets really lose a little bit of mass every trip around the sun, but we'll say it's constant here. And we want to solve for this second speed. So speed 1 times distance 1 divided by distance 2 will leave us with speed number 2. All right, so we started off at 53 kilometers per second, located at 0.69 AU from the sun. And then we want to divide that by 36 AU. So those AU are going to cancel. So 53 times 0.69 divided by 36. And so we get a velocity of 1.02 kilometers per second.